Morning all of you, myself Abdul Ghaffur and welcome to our GFS chemistry channel. Today I am going to deliver an important things related with the isomerism. Every time we may get the confusion related that isomerism. Maybe our JE question or a NEET question like this. What is the total number of isomers for pentane? When I taken pentane, what is the total number of isomers there? Then here formula we know C5H12 is the N-pentane or pentane. How can we calculate that one? You may get maybe the option 6, 7 or 4 one like that. How we clear that one? Before to discuss this one, we have some of the shortcut. Just to follow me. So simple, very easy. Within half minute we are able to get the answer. Then before discussing this one, I want to say some of the point related with the isomers and isomerism. Isomerism meaning what? Same chemical formula, but different structures. That is called as isomerism. That isomerism classified as two. Isomerism classified as two. Number one, structural isomerism. Second category, stereoisomerism. Otherwise, it is also called as space isomerism. Structural isomerism have further classification. Number one, chain isomerism. Listen very carefully. Chain isomerism. Second, position isomerism. Third, functional group isomerism. Fourth, metamerism. Very important, metamerism. Fifth, ring chain isomerism. Last one, isotopic isomerism. This one extra point only for entrance exams. Isotopic isomerism. Then this one, stereoisomerism, classified as three. First one, conformational isomerism. Second one, geometrical isomerism. Then third one, optical isomerism. These we will discuss later. Now we are going along with this category. Just one time I am repeating: chain isomerism, position isomerism, functional group isomerism, metamerism, ring chain isomerism, isotopic isomerism. Here, stereo or space isomerism categorized as conformational isomerism, geometrical isomerism, optical isomerism. Just came back. Here, we are going along with this whole category, metamers and all other structural isomerism. How can we explain that? How can we calculate that? Listen here. First one, the structural isomerism. Structural isomerism. Then here we will get number one. First category, chain isomerism. Formulas are same. Chemical formula same, but structurally they are different due to carbon chain. Structurally they are different due to carbon chain. Just listen here. Take any of the example. Hexane. We know the hexane formula C6H14. Just take 1, 2, 3, 4, 5, 6 carbon. Here H3, H2, 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 H2 and H3. It is an N-hexane. Number of carbon, hydrogen are same, C6H14. Second one, 1, 2, 3, 4, 5, 6th carbon we were taken any of the branch. But one condition, don't take this two end. Here we were taken CH3, here H, here H3, here H2, here H2 and here H3. Now look here, both the formulas are same. C6H14, number of carbon, hydrogen are same, but structurally they are different. What is the reason? It is due to chain are different. When an isomerism arises due to carbon chain, when an isomerism arises due to carbon chain is called as chain isomerism. You get it? So simple. Next one, position isomerism. Second category, that is position isomerism. Position isomerism. Position isomerism means we have a functional group. What is the meaning of functional group? Functional group means when a group can decide the properties of overall that compound. If I have one compound, that compound's properties can be decided by some of the group. That group is called as functional group. Simple. Listen here, position isomerism. Here we take on one compound CH3, CH2, 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 OH. OH will be in first position. Now what is the name of this one? 1, 2, 3, 4. 4 carbon, therefore butane. Butane, we want to cut E. Then add there OH, that means all. That is an alcohol. Butanol. That is then naming time we want to add here 1 butanol, otherwise it is butanol. If I write like this, CH3, CH2, CH2, CH3, 1, 2, 3, 4. Then here I added OH. Now count the carbon, hydrogen, oxygen numbers are same. Then here, what is the name of this one? 1, 2, 3, 4. Then here the name is 2-ol, 2-butanol. Otherwise, what we call this one? Butan 2-ol. Now the name is changed, but the chemical formulas are same. That is called as position isomerism. When an isomerism arises due to change in position of functional group, that is called as position isomerism. Next, third category, third one, functional group isomerism. Functional group isomerism. Here, the functional group are entirely different. Simple example, here CH3, CH2, CH2, OH. It is an alcohol. What is the name of this one? That is called as propanol. Propanol. Propan, E. After cutting E, there we added oil. Propanol. Now, here OH is the functional group. OH is the functional group. Now, here if I written like this, CH3, CH2, OCH3. Count the number of carbon. Here carbon number, how much are there? C3 are there. Hydrogen 3 plus 2, 5. 5 plus 3, how much? 8 are there. C3H8O. Just count this also. C3, H, 5 plus 3, 8. 8, 1 oxygen. Means formula same, but entirely different compound, meaning the functional groups are changed. It is an alcohol, but this one is an ether. What is the name of this one? Methoxy. Nomenclature we want to discuss with the other video. That also so simple. We have so many shortcuts there. This one here, methoxy, methoxyethane. The name is methoxyethane. It is an ether. Then look here, properties are entirely different. Properties are changed. Then this is the functional group isomerism. Now keep in your mind, functional group isomerism generally shown with between alcohol and ether. Alcohol and ether, aldehyde and ketone. Comparison keep in your mind. Maybe the given compound is aldehyde. Then sure, their own functional group isomerism will be shown by ketone, aldehyde and ketone. Otherwise, alcohol and ether. They are shown functional group isomerism. These are the functional group isomerism. Next one, metamerism. Very, very important. Metamers and metamerism. Metamers. Metamers meaning it will be shown only the functional group has divalent. Valency should be minimum 2 required. There only they shown metamerism. Just follow me. Here, when I take a compound like this, CH3, CH2, OCH2, CH3. Here the functional group is O from 16th group. O from 16th group. Oxygen valency 2. Both side has number of carbon. Look here number of carbon equal to 2. Here also number of carbon equal to 2. But this structure I am able to draw like this also. Now also number of carbon, oxygen, hydrogen same. But here changed. How? Here 1 carbon, here 3 carbon, here 2 2, that will be here 1 3. This is called as metamerism. When an isomerism arises due to change in number of carbon on either side of divalent functional group. It is an isomerism arises due to change in number of carbon atom on either side of divalent functional group. Next divalent functional group is sulfur. That we called thio compound, thioether. Instead of this oxygen, when I taken sulfur here, this is called as thiosulfur. Thio compound, thioether. Before that, oxygen we taken there, that one is called as ether. If instead of oxygen we may introduce sulfur, this compound is called as thioether. Now here also sulfur. Okay, divalent sulfur, both side number of carbon equal to 2 here. But here 1 and 3 carbon numbers are different. That is called as metamers. This one is taken as metamers. This property is called as metamerism. Metamerism, don't forget. Then next one, ring chain isomerism. Ring chain isomerism. Look here, one condition. Possible only unsaturated compound. What is the meaning of unsaturated? Saturated means when a compound only have single bond. But when a compound have a multiple bond, it may be double, may be triple. That is called as unsaturated compound. Listen here the chain compound converted to ring compound. Chain compound, one example, when I taken CH2 double bond CH3. This is a compound. Now this one is an open chain, otherwise a chain compound. Now I am able to write like this. Here CH2, here double bond, here CH, here CH3. Now also it is an open chain compound. Now this pi bond will be shifted here. At the same time, from here one hydrogen will be shifted here. Now what we get? Here CH2, here CH. Before this one CH only there. Now one H extra added, CH2. Here also CH2. One bond will be arised between these two. Now look here, it is a closed structure. That closed structure means ring structure. That is equal to, we get this one. Now the conversion, look here the conversion. This type, here also count. Number of carbon, hydrogen, every elements are same. Then only they called as isomers. Now it is a chain isomer, chain compound converted to ring compound. It is called as ring chain isomerism. Now you get the idea why I told, first time I told, possible only unsaturated. If here there is no bond, multiple bond, this structure does not be possible. Here we required this one. This is called as ring chain isomerism. Next one, isotopic isomerism. It's an extra isotopic isomerism. Symbol isotopic. We know sugar and radioactive sugar. Sugar means what is the formula? C12H22O11 is our sugar, eating sugar. That sugar, here carbon, the carbon, which isotope taken there? Carbon has a number of isotope. From there, carbon 12, here 6. Next isotope 14. It's a radioactive isotope. In this case, I chosen for sugar, we chosen which one? This carbon. But instead of that, at least one carbon. Here totally 12 carbon we have. This 12 is the mass number only. Then 12 C12 carbon we chosen for sugar. But for radioactive sugar, at least one carbon will be C12 converted to C14. Instead of C12, there also formula C12H22O11. Here we chosen the carbon will be this isotope. But in this case, if it is radioactive sugar, here we taken the carbon should be C14 isotope. It is called as isotopic isomerism. Now this is the definition for different types of isomerism. Now how to calculate? Very simple. Look here. If I have alkane, if I have alkane, you can apply this formula 2 power n minus 4 plus 1. Any of the, but here one condition, only up to 7 carbon. Shortcut, notice in your mind. Anywhere we are able to apply. Alkane, number of isomers equal to 2 power n minus 4 plus 1. Here n equal to what? N equal to number of carbon. I will explain you. First question, pentane. Okay, we start with the pentane. What is the total number of isomers from pentane? C5. Therefore, pentane, number of isomers of pentane equal to, what we get there? 2 power, instead of n, what we want to add there? N, pentane means C5H12, 5 are there, 5 minus 4 plus 1, that is equal to what? 2 power 1 plus 1, that is equal to what? 3 are there. Shall we draw? Just check it, man. Then here 1, 2, 3, 4, 5 carbon, N pentane, hydrogen you can arrange, CH3, CH2, 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 here CH3, one structure. Second one, 1, 2, 3, 4, 1 as a branch. Third one, 1, 2, 3, 2 as a branch. Try to check any of the other possible. No, not at all. Now we get here only 3 structures. That means our own equation is success suitable. Then there one confusion may arise. Here we may explain with some other meaning. Only we have 3 carbon. 3 carbon are there. That means if you taken propane, what is the total number of isomers? Here number of isomers equal to 2 power n. Prop means C3H8 is our formula. 3 carbon are there. 3 minus 4 plus 1. 2 power 3, here 2 power minus 1 plus 1. One condition, if the 2 power term may be negative, you should neglect, avoid that. We don't want this one, 2 power minus 1. Negative term fully we want to neglect. Therefore, now we will get answer 1. Number of structures equal to only 1. What structure there? 1, 2, 3. Here CH3, here CH2, here CH3. Is any other structure possible? Not at all. Okay, clear all of you? Okay, you may get. Then next one, maybe above 4 are there. above 7 are there. If it is more than 7, that means maybe 8. Octane, we may take an octane. Octane means 8 carbon we have. There you are unable to apply this equation. There you can read by heartly. If it is 8 carbon, now number of isomers equal to 18. If it is 9 carbon, that means nonane. There total number of isomers is equal to 35. If it is 10 carbon, that is decane. Number of isomers is equal to 75. Read this 3 by heartly. Remaining you can apply the method there. Now we have completed only alkane. Similarly, we have a shortcut for alkene and alkyne also. If you choose an alkene, alkene has, first we want to take an even numbered formula 2 power n minus 2 plus 1. Then if it is odd numbered formula 2 power n minus 2. Don't forget, very important. Example, we may take an ethene. If I take an ethene, then C2H4 is the formula. Right here 2 power 2 minus 2, that is equal to 0. Then here plus 1, that is equal to totally equal to 2. What is that? Then here C hydrogen, double bond C hydrogen. This hydrogen we may notice like this, here A and here B, here and here B. What we call this one? It is a cis isomer. C is compound. Then sure, if I drawn like this, see H hydrogen, here A, here B, here A, here B. Look here, A are in opposite direction, therefore it is a trans. Now our equation is verified. Okay, similarly you are able to get all, no matter. Don't take a confusion, don't take risk related to this one. Just simply apply. If it is even numbered, you know, even and odd numbered. Even numbered 2 power n minus 2 plus 1. If it is odd numbered 2 power n minus 2 only, that is enough. Clear all of you? Next we have one more alkyne. If it is alkyne, third one alkyne. First here also, if the compound is even numbered 2 power n minus 2n minus 1, apply this equation. If it is odd numbered, formula 2 power n minus 2n, this is enough. Very simple equations. 2 power n, just try to verify this one. Maybe 4 carbon, C4 are there. What we call this one? Butane meaning totally 4 carbon are there and 1 triple bond also there. It is an even number. Then now you can apply 2 power 4 minus 2 into 4, that is equal to what? 2 into 4 minus 1. You will get the answer. That is right. Similarly, if it is an odd numbered, apply this one. Maybe 5 are there, that means pendyne. Pendyne means what is the total number of carbon? C5 are there. Then 2 power 5 minus 2 into 5. Sure, you will get the answer. How much is simple? Try to apply and try to reduce your time. That much easy. Then maybe you want to calculate only number of open chain isomerism. If you want to calculate next formula for an open chain, you required only no need closed, open chain only required. Some of the question paper 2014, some paper has this question. Alkyne they given, some examples alkyne, maybe hexane, heptine they given. What is the total number of open chain isomerism? If you go on with the reading structure or drawing structure, sure your half an hour will be lost only for 4 mark. Then very shortly we are able to calculate this one. For open chain we will get this one, n into n minus 2. N is the number of carbon. Clear all of you? Okay, please like and share GFS chemistry channel. Okay, bye.